Well, good morning, good afternoon, depending on where you're looking from. Welcome to the Kopernik Observatory and Science Center. My name is Drew Desker. I'm the director here at Kopernik, and we are very excited about this event this afternoon, or this morning, where our students here at Kopernik will be talking to Colonel Bob Hines on the International Space Station. So a little bit about Kopernik. We are closing in on our 50th anniversary. We are an observatory, a public observatory here in upstate New York. And we also run a range of STEM classes for students, really of all ages, quite frankly. But right now, we're focused on our summer camps. Our summer camps are associated with the Link Foundation. Edwin Link was the inventor of the flight simulator right here in Binghamton. And his foundation helps us underwrite a portion of what we do here at Kopernik. The camp we're doing this week is called Welcome Aboard the International Space Station. It's an opportunity for students that are going to be entering 4th and 5th grade to learn about what it takes to become an astronaut, what kind of training they go through as an astronaut, and they'll also learn about the International Space Station itself. In fact, on the first day here, they actually were welcomed aboard the ISS with a virtual tour of the ISS. One of our instructors, Jeremy Carty, had his VR headset here, and he projected what he was seeing up on the screen, and they toured through the entire International Space Station. They're actually building their own space station model. They also had a conversation with Dr. Joe Dervais, who actually is a Johnson City native and is now a flight surgeon for NASA down at the Johnson Space Flight Center, and in fact is the physician, the doctor for these astronauts. And so he talked about the work that he does as a flight surgeon and working with the astronauts. So the students will also be doing some other activities. They'll be actually building their own antenna that could actually talk to the International Space Station if they had their ham radio license. So those are the kinds of things that they will do with this camp. And we may not be turning everybody here into an astronaut, but hopefully we're planting some seeds for potential STEM careers in the future. Also joining us here is some younger students in our Secrets of Code camp, and it's great to have you here with us as well. So what I'd like to do now is I'm going to play a couple of videos for you that sort of give you a little bit more information about the ARISS program. ARISS, by the way, means Amateur Radio on the International Space Station. And so we'll get to hear from Tim Peake in this first video.
One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now, these are events that are planned by ARISS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering, and mathematics. Now, this is the equipment here in the Columbus Laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now, as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now, because we're traveling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus Laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARISS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
Now, as it turns out, we I think are closer to 2,000 amateur radio contacts at this point. This has been a great resource, and they've been doing that. Amateur radio is actually one of the longest running experiments that has been on the ISS. The ISS was actually started construction in 1998. It has been populated. Somebody has been on the ISS since 2000. There's always been somebody on board the ISS since 2000. So amateur radio has been a great resource, not only to the astronauts, but ultimately to the general public as well. So now I want to run another video by you here, and this is actually, here we go, a couple of people closer to your age.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station. But it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code. And then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted
Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS.
That's Doug Hurley from Windsor.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. we have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARISS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
All right, so that gives you a little sense of what exactly is going to happen and what we needed to make it happen. I also want to, before we get started, the actual contact will probably start somewhere between 8 after and maybe 11 after the hour. So we have maybe somewhere between 10 and 13 minutes or so before the contact itself will actually start. And the reason for that, the uncertainty, is that now, the International Space Station normally flies out about 250 miles above the Earth. But because it's in microgravity, it's actually constantly being pulled down into the Earth. And then every once in a while, they have to boost it back up again. And then it keeps falling down, boosting it back up. Well, this morning, they actually did a boost. So when they do that boost, it'll actually push it into a higher orbit, which sort of, I don't want to say it doesn't slow it down, but it makes the orbit a little longer. So we'll be calling out probably a number of times before we finally get in touch with them. I also want to introduce a couple of the people here that have been part of this whole process. Joining me as a teacher is Tish Rissy, who's a JPL NASA System Ambassador. Also, Jeremy Carty is right now helping drive our live stream, and again, I'm Drew Desker. We also have interns, high school interns, Aiden, Sasha, Zach, Emma, Sophia. They're all helping us out here. All right, so what I want to do now is give you a little bit of introduction to who we're going to be speaking with. This is Colonel Bob Hines.
I truly believe that we all have in us an innate desire to go explore and see new things, and we have this phenomenal creation that we've been placed in to learn about how it works. We have a very unique position in our solar system and our galaxy to be able to look out there and to step out and continue to explore. My name is Bob Hines. I'm the pilot for NASA's SpaceX Crew 4 mission to the International Space Station. I was born in Fayetteville, North Carolina. My father was in the Army. We were stationed at Fort Bragg, and we moved around a whole bunch. The longest we ever lived anywhere was about 2 to 2.5 years. I got really comfortable showing up in new places and being able to make friends. When I was a kid, I 100% wanted to be a pilot for as long as I can remember. I was just always fascinated, not only that something that big could fly and do some amazing things, but also just the opportunity to go and see things that not many people have had a chance to do. Being able to fly and see the Earth from a new perspective has really been just a real driver for me, and getting hired as an astronaut has been the ultimate call. Contrary to popular belief, being a test pilot is not about flying by the seat of your pants and going out there and just pushing the edge of the envelope all the time. It is a much more scientific and methodical process where we plan out every mission and all the tasks on every mission, and we're constantly mitigating the risks that are associated with that mission. That seems to really dovetail very well with spaceflight because that's a lot of what we do. My experience as a test pilot and as a pilot and an instructor, I think have all kind of led me to this point. When I got the phone call offering me the position of the pilot on the Crew 4 mission, it was absolutely amazing. It was actually the day after my birthday when I got the phone call, and I just couldn't believe it. When I told my wife, she couldn't believe it either. I've flown over 3,500 hours in more than 50 different kinds of airplanes, and that ranges from gliders all the way to different kinds of fighter airplanes or large transport category airplanes. I can't wait to pilot this vehicle. It is an incredible honor, and it's something that I never in my wildest dreams thought would be a possibility. And so to get a chance to pilot one of the newest vehicles on or off the planet is a true honor. With Chell as our commander and Samantha and Jessica as our mission specialists, it's just going to continue to be an amazing crew and an amazing experience. I am really looking forward to the camaraderie and the time that we'll get to spend together as a crew, the friendships that we'll develop, and so I think continuing that process is one of the things that I'm looking most forward to. On launch day, I am 100% most looking forward to the kick in the pants when those rocket motors light and we are heading off the launch pad. It is going to be the culmination of a lifehood dream, something that just spend your entire life looking for and not ever sure that you're actually going to achieve it.
Our newest astronaut, Bob Hines.
Being an astronaut is an incredible responsibility as well as an incredible honor. Every astronaut recognizes the honor that comes with that, but also the responsibility that comes with representing not only our respective countries, but also the world. And one of the things that we hope to show is that regardless of our nationalities or our backgrounds, when we put our mind to a single mission and we get along, we can accomplish anything.
All right, let me talk a little bit about what we're seeing here up on the screen. And this is a version of the tracking program that we are using. So our radio itself is actually over in the observatory. We've got a computer link that takes our audio and brings the radio audio back to us remotely. But what we're seeing here is a tracking program called SAT-PC32. And looking up here on the screen, you see, right now we're seeing North America and most of South America, but you see this white disk here. This white disk is what we call the satellite footprint. That is how much of the Earth the ISS can actually see. And we actually, one of the things that we did first with the students is we brought out a globe that was about 1 foot in diameter. And I said, well, if we were in the ISS and using this globe as a proxy for that, how high off the globe would the ISS be? It's actually 3/8 of an inch for if the globe is one foot across. So as long as our position, which right now is that little X up here in New York State, as long as this white disk is in that X, we should be able to hear and communicate with the ISS. So these little white dots here are not Pac-Man pellets, but they are actually the ground path. So you'll see as it's moving along, this is like right now, if I were in the Baja Peninsula, if I look straight up, that's where the ISS would be at the current moment. Now, down in the lower left-hand corner, there are these two numbers. One's called azimuth, one's called elevation. Azimuth is basically it's helping us understand where we need to aim our antennas. So azimuth is north, south, east, or west. So north was what degrees? 0 or? 90. North? 360, right? And east was? 90. South was? 180. West is?
277.
And north is? 360. Okay, right. So right now, from our location, the ISS is at 252 degrees of azimuth, so it's in the southwest, although it's at negative 9.6 degrees of elevation. So we can only talk to the ISS when it's above the horizon, because we have to punch our radio signal through the ionosphere. So in a few moments, let me also introduce, this is Gary Dewey. He is a ham radio operator. His call sign is AB2GD. And he will be the person hitting the transmit button, which is what legally he's the one that has to do that. And then our students will get ready to make ask their question. So what I'm going to do is I'm going to ask our students to get in line like we did for rehearsal. And what we're going to do here is we're going to start a little bit early because of that reboost, we're not sure exactly where the ISS is, so we are going to try calling a little bit early. So Gary's going to call, and he'll probably do this maybe even a dozen times until we finally hear Bob Hines has returned the signal, and then as soon as we do, we'll just start our questions. So we have another minute or two. Let me see, I can explain this a little bit more. So right now, according to this tracking program, AOS means acquisition of signal. Will begin at 12:08 local time, and LOS, loss of signal, is supposed to be at 12:19. So it thinks we might have up to 10 and a half to 11 minutes. So we'll see how good we are with that. Again, we've got 19 questions that we have to ask, so in 10 minutes. So we were just like blocking like the Rockettes. We had everybody just right next to each other, ready to go with their question. And now you also notice that down here it says height, and it says 416, but this is in kilometers. So 416 kilometers is about 250 miles or so. Current range is 2,828, 21, 15. So every second you can see, it travels almost 5 miles a second. I tell people you can get from here to downtown Binghamton in a second and a half. And so we are going to be starting to, I've got 12:07. So in a moment or two, we are going to have Gary start calling, and we'll see when we start hearing his response. All right, I'm going to go make one adjustment on the radio, but I would say, Gary, go ahead and start giving him a call.
Alrighty. NA1SS, NA1SS. This is K2ZRO, Kilo 2 Zulu Romeo Oscar. Do you copy? NA1SS, NA1SS. This is Kilo 2 Zulu Romeo Oscar. Do you copy?
Kilo 2 Zulu Romeo Oscar, this is NA1SS. I have you 3x5. How many over?
Thank you. Welcome to Kopernik Observatory and Science Center. Here is our first question.
Hi, my name is Ramin, and my question is, what was going through your mind going from Earth to space? Over.
Yeah, great question. When the engines first lit off, the first thing that went through my mind is, I guess we're really going. And then after that, the training kicked in, and I was very much thinking about the procedures that we needed to do and to make sure the vehicle was acting right until engine cut off, and then that was the first chance that I really had to sit back and enjoy it and look out the window, and it was just amazing.
Okay, go ahead.
Hi, my name is Connor, and how do you stay in touch with your family so they know you're okay? Over.
Connor, that's a great question. We have an IP phone, which is a phone through a computer, and so we're able to call home almost every day if we want to. And then once a week we get video conferences, so like a FaceTime call where we get to see them through a camera on the computer. And so it's pretty good up here. We get to see them pretty often. Over.
Hi, my name is Jim. How does a magnet act in space? Over.
Hey, Liam, the great thing about magnets is they are not really subject to gravity. So up here they act exactly like they do down on Earth. And if you put the two like poles together, they repel each other. It's just they're not pulled to the ground, and so they can just float away from each other. Over.
Hi, my name is Dylan. What do you do for fun activities? Over.
Yeah, we have lots of fun up here. One of the things that we all enjoy doing is going and looking out the window because it's such a unique view. So something we'll do is go look at the cupola out the window, and then other things we do are call home and call our families, and that's always fun to talk to them as well. Over.
Hi, this is Freddie. After a long journey in space, how long did it take for you to learn how to walk again? Over.
Hey, Freddie. Well, this is my first space flight, so I haven't been back yet. I will let you know. But from what I've seen from other astronauts, it's like riding a bicycle. They pick it up almost right away. They might be a little wobbly because their balance isn't very good, though. So that'll take a little while to come back, maybe a week or so. Over.
Hi, my name is Lucas. What does the Earth look like from the space station? Over.
Hey, Lucas, it is absolutely amazing to look at. I'm sure you've seen pictures and things like that on the internet. Those don't even live up to it. It is so much, the colors are so much brighter and bolder. It is just absolutely beautiful. Over.
Hi, my name is Cadence. Who is your role model? Over.
Hey, Cadence, that's a really good question. So I am a Christian, and so Jesus is my role model for how I should love people and treat others. But also my grandfather and my dad are role models as well. Over.
Hi, my name is Allie. What was your favorite moment in space? Over.
Hey, Allie, my favorite moment was actually right after our engines shut off on launch, because it went from we went from vibrating a lot and shaking and really loud to total silence and being weightless, and then the view out the window was absolutely spectacular. Over.
Hi, this is Daphne. How do you prevent sickness in space, and if you get sick, how is it treated? Over.
Hey, Daphne. So we quarantine for 2 weeks before we launch to try and keep us from getting sick. But if we do get sick, we have doctors on the ground that can support us by using cameras and things like that. And we also have some medications up here we can use. Over.
Hi, my name is Lucas. What kind of experiments do you perform on the International Space Station, and how would these experiments be different in gravity? Over.
Hey, Lucas, that is a great question, and it's a really hard one to answer. We do over 250 different kinds of experiments up here, and every one of them is a little bit different. But removing gravity lets us learn about how different systems work. So it is pretty amazing. We have some robots up here that float around, and they wouldn't be able to float around if they were on space station, but they float around and do all different kinds of work. Over.
Hi, my name is Erica, and I was wondering, what does it feel like to be weightless? Over.
Hey, Erica. Well, it is just amazing. If you've ever gone on a roller coaster, that little drop in your stomach that you feel at the top is what it feels like when you first do it, when you first become weightless. But then your body gets used to it, and it just feels normal, except that you can float around by just using your hands and gentle pushes to drift everywhere you're going. Over.
Hi, my name is Callan. What is the coolest or craziest thing you have seen from up there? Over.
Hey, Callan, I think the coolest thing that I've seen so far up here is actually the Earth. As we travel around, it changes every time we come around. The weather's different, the clouds are different, and it is just absolutely amazing. But also the aurora are just awesome to watch. Over.
Hi, my name is Allison, and can you see the aurora from the ISS and take pictures of it? Over.
We sure can. We can see them every time we get mostly to the South Pole right now because of the summer. It's darker down there. But we can see the aurora every time we come down to the South Pole, and we can take pictures of it. And if you Google it, you'll be able to see lots of pictures and videos of the aurora. Over.
Hi, my name is Sophia. Do astronauts play music instruments in the space station? Over.
Hey, Sophia. Well, some of us do, just like you guys. We all have different interests. And we have one of the cosmonauts, the Russian astronauts, that plays a guitar. So he has an electric guitar up here. Over.
Hi, my name is Helena, and what is your favorite part of being on the ISS? Over.
Hey, Helena. My favorite part is being part of the teams that get the amazing mission done up here and getting to do all the different experiments. Over.
Hi, my name is Leafin. I read that water and oxygen is recycled on the ISS. How much total water and oxygen is needed per astronaut in space? Over.
That's a great question, Leafin. I'm not really sure how much each of us needs, but we recycle 96% of all of our water. So it's really good and helps people on Earth as well with that technology. Over.
Hi, my name is Chris, and how can I be an astronaut like you? Over.
Hey, Chris. Well, the best thing you can do is be an astronaut like you. My advice is to find something you're passionate about and work really hard at it. And with hard work and dedication, anything is possible. So shoot for the stars. Over.
Hi, my name is Avery. What is the most challenging thing about leaving your family for space? Over.
Hey, Avery, that's a really good question. It is just hard leaving them and being away from them, especially over the summer when my kids are not in school and I don't get to be there with them. But we do get to talk pretty often, so that makes it better. Over.
Hello, my name is Edison. What special exercises do you have to do to stay healthy in space? Over.
Hey, Edison, it is really important for us to exercise. We do it for 2.5 hours a day. We have a weightlifting machine that we spend about an hour on and does all different kinds of exercises. And we also have a treadmill and a bicycle that we use. Over.
Hi, my name is Aiden. Thank you very much for answering our questions. Over.
Hey, thank you all. It was great talking with all of you today. I hope you have a great time and keep shooting for the stars.
Colonel Hines, this is Drew Desker. I'm director up here, and I was just we were talking with Dr. Joe Dervay yesterday, and he tells me that you are a rabid hockey fan. Which team are you a fan of? Over.
Oh, yes, Dr. Dervay, I just talked to him a few minutes ago, and he mentioned that as well. I am, I don't know if you guys are going to like this, but I am a Pittsburgh Penguins fan as a Pennsylvania guy. Over.
Yeah, transmit again. All right, well, thank you again. We really appreciate your time. I'm not sure if you had your dinner yet, but otherwise, bon appetit for this evening, and thank you again for what you and all your colleagues do up there for ARISS and for inspiring this next generation of scientists and engineers. So thanks again, and safe travels. Over.
Hey, thank you so much. Thank you for what you guys do, and to all the kids, good luck to you. It was great talking with you, and hopefully we get to meet in person someday. Over.
All right. Thanks. Okay, you go ahead.
Anyone SS, this is Kilo 2 Zulu Romeo Oscar 73, and thanks for the contact.
All right.
Kilo 2 Zulu Romeo Oscar, thank you much. Take care. 7-3, over.
All right, this doesn't happen. We actually went through all 19 questions and still had time to have a sort of a casual conversation. So again, thank you again for your time, and we'll look forward to seeing you back on the ground. And hopefully, if you ever get back up to upstate New York or up into Pennsylvania, head up 81, and would love to have you up here at Kopernik Observatory. We're just about an hour north of Scranton. Over.
Oh, that's perfect. I went to school just outside of Wilkes-Barre, so not too far from my old stomping ground. So hopefully we'll get to touch base sometime.
Yep, 73, and have a good evening. This is K2ZRO. Thanks again.
And copy likewise to you. This is NA1SS 73.
That doesn't happen. that was outstanding. That we had all 19 questions. Actually, we had a 20th with Aiden offering his thanks, and you guys did a fantastic job. And I hope, yeah, exactly. And I hope you in the Secrets of Code Camp got to enjoy that, and we try to do this every 2 years. Now, we can't guarantee that NASA will allow us an opportunity to do this, but in 2 years, you could be the one sitting in this seat asking your question to the astronaut. So we look forward to having you come back here. I want to thank you, the parents watching, and we also understand that we had a little difficulty with our original stream, but I think a number of people did move over. We will ultimately find a way to put this together as a video, and we'll put it up on the Kopernik's YouTube stream. So thanks again, and we'll see you soon.